Hi everyone, welcome to IGNOU's classroom. In this video, we are going to learn about sampling distributions, and this video is a part of MMPC 5 playlist. So, a few of the things that we'll be discussing here are sampling distribution of the mean, central limit theorem, sampling distribution of variance, students t distribution, sampling distribution of proportion, interval estimation, and sample size. So, let's get started. Now, what is a sampling distribution? Once we have created or selected our sampling methods and actually went and collected those samples, the next thing that we do is to create sampling distributions. A sampling distribution is a probability distribution of some statistic. Okay, a statistic is what you can say a characteristic of the sample. A characteristic of the population is called a parameter. Similarly, a characteristic of your sample is called a statistic. And that statistic definitely will be obtained from a large number of samples that are drawn from a specific population. Now, this sampling distribution of a given population is the distribution of frequencies of a range of different outcomes that could possibly occur for a statistic of a population. Now, the reason why we go and create sampling distributions and study them is because these sample statistics is what forms the basis of all the inferences that we will be drawing about the larger population. If we know the probability distribution of a sample statistic, then from that we can calculate the probability that sample statistic will be similar to the or will be assuming a particular value when related with the population. Okay. Now, sampling distribution of the mean can be thought of as what you can say for a certain sample of let's say 50 people. What will consider the example of we are trying to find the mean height of people in Thrissur district. Okay, so if we are collecting 1,000 people as sample who are from Thrissur, and we are finding the mean height of those 1,000 people, then what you can say the sample distribution of this mean height will behave according to or the mean height of the sample will behave according to this distribution of the sample. Okay, so any random draw from the sampling distribution can be interpreted as the mean of the sample of n observations from the original population. Now, to create a sampling distribution, a researcher must first select random sample of a specific size n from the population, calculate the chosen statistic for the sample, plot the statistic on a frequency distribution, and then repeat these steps an infinite number of times in order to create the sampling distribution of the mean. So the thing is, like if we create a distribution of the sample, okay, say we have collected the heights of around 1,000 people, and if we are to plot that as a graph, we will find out how the heights are distributed. Okay, and if we collect say 20 samples, each of 1,000 numbers, okay, so that is a total of 20,000 people, and we find out the mean of each of these sample sets, so we'll have 20 means. Now we are plotting a distribution of these 20 means, that is sample distribution of mean. Okay, now coming to the central limit theorem, it is a statistical theory which states that when the large sample size has a finite variance, then samples will be normally distributed and the mean of samples will be approximately equal to mean of the whole population. And a few frequent what you can say application of the central limit theorem is in the political or election polling. Okay, wherein these polls we are conducting and using to estimate the number of people who might support a specific candidate in order to find out our chances of winning. There are a few assumptions in central limit theorem, in the applicability of central limit theorem, and they are, first and foremost, if we are to apply the central limit theorem, then we should make sure that we are applying simple random sampling. Okay. Second is that samples should be unrelated to one another. And when we are taking samples without replacement, then the sample size should not exceed 10% of the population. Sampling distribution of variance. So similar to mean, if instead of mean, if we were to take the variance and plot it, it will become sampling distribution of variance. Okay, so we use the sample mean to estimate the population mean when the parameter is unknown. Similarly, we use a sample statistic called the sample variance to estimate population variance. And the sample variance is usually denoted by S square, and it captures S2, and it captures some kind of an average of the square of deviations of the sample values from the sample mean. So the deviations are measured from the sample mean and not from the population mean. And secondly, sum of the square deviation is divided by n minus 1 and not by n. So consequently, we can calculate the sample variance based only on the sample values without knowing the value of any population parameter. Okay, so the sample variance, it is denoted by S square, okay, and not S2. It is denoted by S square. And this is the formula for calculating the sample variance. Now, coming to students' t distribution. The t distribution is a type of probability distribution which is similar to normal distribution because it also has the bell shape. But compared to normal distribution, the students' t distribution will have a heavier tail, and therefore it is used to estimate population parameters for small sample sizes or those which has unknown variance. It is used to make presumptions about a mean when standard deviation is not known to us, and it is used to compare the means between two groups. Now, coming to sample distribution of proportion, if we take repeated random samples of a given size, say n, from a population of values for any categorical variable where proportion in the category of interest is p, then the mean of all sample proportions, okay, is the population proportion p. Now, for large samples, the sample proportion is approximately normal distributed with a mean we denote as mu and a standard deviation which we denote as sigma. Now, a sample is large if what you can say the interval p minus 3 times sigma raised to p and p plus 3 times sigma raised to p lies wholly within the interval of 0 and 1. Coming to interval estimation, the sampling distribution of a statistic actually helps us in developing a confidence interval for corresponding population parameter. And the confidence level may be defined as the probability that the interval estimate will contain the true value of the population parameter which is being estimated. A confidence interval actually refers to the probability that a population parameter will fall between any two sets of values. The confidence interval is the percentage of times actually that you can expect to get close to the same estimate if you are to run your estimate or experiment again or resample the population in the same way. It consists of both an upper and lower bound of the estimate that you expect to find at a given level of confidence. Like for example, a confidence level, let's say you are conducting a research on what you can say the average marks that a person, or let's say no, the average height, okay, of people in Thrissur itself, or anywhere in your district or in your village, okay, and you have found that most of the people have a height of, let's say, 5 feet 2 inches, okay. So if your confidence level is 95%, means you pick up any person, then 95% you are sure that their height will be 5.2 inch, sorry, 5 feet 2 inch, okay, or maybe let's say 158 or 160 centimeters, let's say. 95% you are sure that if you pick up a person from this population, from your village or from your district, their height will be 160 centimeters with 95% confidence. 5% it might differ, but 95% you are sure means that is your confidence interval, okay, or confidence level. And so the sample size actually depends a lot on this confidence interval or this confidence level. If we assume that the population distribution is normal and population's standard deviation is known, then the sample size required for a given confidence level and a required accuracy can actually be determined. But if we want to estimate the sample size, then we will need to take in order for it to give us that particular mean at a certain confidence level. Then we have to use the sample proportion, say p dash, to estimate the population proportion p. And if n is sufficiently large, then the distribution of p dash can be approximated by a normal distribution with a mean of p and variance of p into 1 minus p by n, where we are assuming that q is 1 minus p. So p into q divided by n will be the variance. So from the examination point of view, from this unit, I would say you need to know what central limit theorem is most importantly, and then what do you understand by in interval estimation, or what is students t distribution, what is the sampling distribution of mean, like that. You need to have an overall idea about what these concepts are. We have not seen any practical questions that has been asked from this unit. Okay, even the theory questions have been very limited, and most of the times it is maybe central limit theorem that gets asked, or maybe what you understand by students t distribution or things like that. So the basic idea, and while you're preparing in by keeping term and examination in mind, that is what you need to focus on for this particular unit in MMPC 5. Okay, and if you are actually focusing on how to, or where does all these concepts fit in, then I am really sorry to say that the content that has been provided in the material is not wholesome enough for us to get the proper big picture. So from the term and examination point of view, this will be more than enough. But in case you are interested in exploring more and actually making sense out of the whole concept that we are studying in MMPC 5, then let me know in the comment section below, and I will see if I can create an entire playlist or separate, or an entire course wherein we are actually we will learn in depth without any time constraints, in depth on each of the concepts, and how exactly where these puzzle pieces fit in the, you know, in the bigger universe of statistical analysis and data analysis and things like that. Okay, the business intelligence part. If you are interested, let me know in the comments. If I get enough responses, then definitely I will plan a separate course on it at the earliest. All right. So if you want the PPTs for this, then I will leave a link to it in the description. You can go to the link and download the notes. Okay, it will be available free of charge. And if you like the video, let me know by giving a thumbs up. If you did not, then you can express that as well. You know where to. If you have any doubts, you can post it in the comment section, and I'll try to answer it the best I can, either as a comment reply, or I will, if required, create a video. But I'll surely try my best to resolve your doubts. So until I see you in the next video, it's bye-bye for now.